This is one of a series of short videos showing how to do computational physics. In this video, we'll be looking at loops in MATLAB. As usual, we start with the MATLAB IDE main window, and we will start a new script by clicking on the appropriate menu item. And you can see that an editor has appeared, and we're going to put a few line breaks in to make entering lines of code a little bit more easy. And as usual, it's good practice to put a comment on the code. So I'm going to type loop example, something like that. And we're going to now enter a loop. Now, what is a loop? Well, a loop is a means of having some value iterate over a sequence. And we already saw that in a previous video when we generated a set of values using the so-called colon notation. And I'm going to put the colon notation here to generate the numbers from 1 to 4. And I'm going to put in a for statement at the beginning, and I'm going to assign a variable n to take on the values from 1 to 4. And when I enter the for statement, you will see that it, as a little red highlight appears underneath the for statement that tells me something about the debugging that might be needed for this line of code, because this statement is not yet complete, and it says an end statement might be missing. So the debugger within MATLAB is pretty good, but it doesn't always know unambiguously what's wrong with your code. So you can see that a bracket has appeared, highlighting that there should be an end statement somewhere, and I'm just going to click here, and I'm going to type end, and you will see that now the bracket matches the end statement. So everything that lies between the starting for statement and the end statement may be executed several times for each value of n. I'm going to put my cursor at the end of line 4, at the end of the number 4. I'm going to hit return, and you'll see that when I do that, the cursor is now indented away from the left-hand side. And this is not needed. You can enter code any way you like on the intervening lines, and it will still execute fine. But having it indented in a consistent manner, which MATLAB will do automatically for you, as you can see, having it indented will make the code easier to read. So what can we do with these iterated values of n? Well, to begin with, let's just display them. So I'll do disp n, putting a semicolon on the end. And this is a complete working example of a loop. So let's see what it does. I'm going to press the run button. And you'll see here that because I haven't yet saved the script file, the MATLAB has prompted me to enter a file name. So it wants me to save the file before I execute it. So I'll type loop example. And you'll see on the left here that the .m extension has been added on as usual. And what's happened in the command window? Well, of course, when I press the run button at the top here, in the command window below here, you can see that MATLAB, when I press the run button, has executed loop example.m, and it has evaluated line 5 several times, once for each value of the numbers in this definition here in the for loop. So n has been defined and can therefore be displayed in this statement here, and it's now been displayed 1, 2, 3, 4 as we would expect. But also notice that once the for loop has completed in MATLAB, the number n, the variable n, is still available in the global scope of MATLAB. In other words, it's available everywhere. So that's something you need to be a little careful of, because it's a little bit different from some other programming languages. So that's how we can do a for loop. Is there anything else we might do that's a little bit more sophisticated? Well, obviously it's very easy to enter in large values. So we can run that again. You can see now I have 100 values in my display statement. Can I enter some other values? Well, let's try non-integer values. Let's put 0.1 in, as we did when we used this colon notation in the command window. I'm going to execute that again, and you will see a very large number of values has appeared. We can scroll up and you can see that all the values between 1 and 100 have been created in steps of 0.1. And notice that in MATLAB, in a MATLAB script, we don't need to predefine at the top of the script what type of variable n is. So MATLAB is a weakly typed language. It doesn't care what type has been assigned to the variable, whether it's an integer, a floating point number, or something else. MATLAB will dynamically change the definition of n depending on what we apply to it. So if n is defined as being an integer, n will become an integer, and if n is defined as a floating point number, it will become a floating point number. Now, I don't just have to go upwards, I can also go downwards. So let's re-enter a new set of numbers. Let's do 10, I want to go to 0. Let's put some colons in between and go down in steps of -1. And that will work. As you can see, I go from 10 to 1. So as long as this colon notation yields a sensible set of values, actually an array of values which are put one at a time and assigned to this variable n, as long as this colon notation works, then I can assign values to n that can be used. So let's have a look on the command line, and I'm going to do 1 in steps of 2 up to 10. That will generate the numbers 1, 3, 5, 7, 9, remembering that the final value isn't necessarily utilized. The iterator, this +2, is applied to 1 progressively until the value that's generated falls outside of the final value, and then the iterator will stop, the iteration will stop. So if we put that into the command the editor window up here, okay, and we run it again, you will see that I get 1, 3, 5, 7, 9, just as I would have done if I did it using the colon notation. So obviously I can generate a sequence of numbers using a for loop, but it'll mostly be more convenient to do this activity without using a for loop, because we can use the colon notation directly to give us those numbers. Can we do something that's more interesting, which we can't easily do using the colon notation by itself, and for which we might need a for loop? Well, let's do some kind of calculation where I do a summation. So I'll start with, I'll call this sum equals 0. Always remembering that I should check to see whether that is a reserved word. You see that 4 is highlighted a reserved word and sum isn't because it's not in blue, but it's now available. So we'll do sum equals 0, and I'll do sum equals sum plus n. I put a semicolon on there to stop displaying each and every value, and then I can disp sum at the end. And if I run this, you'll see that I've now summed all the odd numbers up to from 1, 3, 5, 7, 9. So just to check that's working, I'll do 1 plus 3 plus 5 plus 7 plus 9, and as we'd expect, of course, it's 25. So that's one example of using a for loop to allow me to do more than I could easily do with this colon notation up here. Now there is an alternative to using a for loop which is a little bit more flexible. I'm just going to go back to what I had before. I'm going to just display the value of n within the for loop. I'm going to delete these bits and these bits. And instead of using a for loop, I'm going to use one of the other constructs which is available within MATLAB, which is called a while loop. And just as I can do with the for, I can look for the help for the while loop, and I look up here and you can see that the while loop is asking me to do something similar. It says while an expression, and it says repeat statements an indefinite number of times while the real part of the expression has all non-zero elements. What does that mean? Well, let's put an example. We'll say while, and we'll say n is less than 10. Okay, I'm going to say disp n and say n equals n plus 2. So I'm going to count up through those odd numbers that I had before. So I'm replacing that 1, 3, 5, 7, 9 display that I had before using the for loop, and I'm going to do it with a while loop. And notice that I need this extra definition at the top, because until I've defined what n is, I can't add something into it in here. So this while loop doesn't automatically iterate through a sequence of values. I have to do that iteration manually myself. So I can define n equals 1, I can add 2 to it each time, and I can display the value as long as the current value is less than 10. So let's run that. And you can see that I get 1, 3, 5, 7, 9 as I did before. So this is basically equivalent to the for statement that I had previously. So you might wonder, well, what's it useful for? Well, let's try something else. Let's see if I can add a random number instead. Let's do help. Now, what would the random function look like? Well, let's try help random. Is that a function? Ah, That looks a bit complicated, doesn't it? Random. Oh, that seems a bit complicated. Maybe there's something similar, more simple. Well, MATLAB sometimes doesn't help us very well to find the functions we're looking for. Let's just type help rand. Ah, there we are. That's a little simpler. We'll go up to the top here, and we'll say rand. A uniformly distributed pseudo-random number. So if I call rand n, it returns an n by n matrix. So if I scroll down the bottom here and I say rand 2, it creates, it's not really what I want. Let's try rand 1. Okay, that generates a single value, which is what I want in this case. Let's see what happens if I omit the argument altogether. It still works. I still generate a random number. So notice here that a couple of things are true as they are elsewhere in MATLAB, that functions will often assume that you're looking for a matrix to be generated, and sometimes functions you can omit the argument entirely. So I'm just going to add rand instead of 2 here in my while loop. Okay, so this is going to add random numbers to n until the final answer becomes greater than 10. Okay, so I'll just save that as well, which I've not been doing so far, but I'll run it, and you can see that random numbers are being added to the initial value, which I've set to be 1 here. Okay, random numbers are being added. These random numbers lie between 0 and 1, so the numbers are incremented until I get above 10. So this is something I can't easily do with a for loop. So you can see that the number of iterations the while loop generates doesn't have to be a constant, doesn't have to be predefined. It will be slightly different each time. That may not be entirely clear here, but let's put an iterator in so we can see how many times that while loop has been running. So we'll say I equals 0, and each time the while loop is running, I'm going to do I equals I plus 1, and as well displaying n. At the end, I'm going to display how many iterations were used. So I'll run that. And you can see that there are 17 in that one, 19 in that one, 20 in that one, 18. Okay. So that shows that a while loop is very useful if I want to set a terminating condition, but I don't want to predefine how many iterations I'm going to have. So those are the two basic sorts of loops that I can use in MATLAB, the for and the while loop. And in the following videos we'll show in a bit more detail how they can be used for doing more complicated calculations.